So what if a lot of planets that might host life out there don't actually look like planet Earth at all, but instead look like this? What if they're all unusual ice worlds with a very large ocean underneath that has plenty of life to go around? And what if we actually have a way to prove all of this by looking right here in the solar system? And so, hello wonderful person, this is Anton. Today we're going to discuss a relatively recent study that makes a very intriguing proposition that there could be 17 known exoplanets out there, not so far away from us, that could be extremely similar to something we have right here in the solar system, which are of course ice moons. Moons like Enceladus. And they might have extremely similar effects to Enceladus, with extremely large oceans underneath the shelf of ice that protects all of the life living on the inside. And so let's discuss this in a little bit more detail, but let's actually start with a lot of discussion about Enceladus in the last few months. And here I wanted to start with the webpage you can find in the description below. This is known as NASA's EYES, or Eyes on the Solar System. But in this particular case, we can actually take a look at Saturn and its moons by, clicking right here, and then clicking on Enceladus. And the reason I wanted to take a look at this in this particular website is because it also simulates the geysers. You can see them being emitted from this area that looks like unusual tiger stripes, and you can actually learn more about this in one of the videos in the description, including how all of this works. But here, by accelerating time, you can even see the emissions almost as if you're right there around Enceladus. Although technically these are not geysers as much as they're cryovolcanoes. And the reason this is so exciting for scientists is because there is now a very strong belief that based on a lot of observations from the last few months, currently there's a really high chance that a lot of these cryovolcanoes are also emitting signs of potential life underneath Enceladus. In other words, Enceladus currently is the most likely candidate to find life outside of planet Earth. Not Mars, not Venus, not any other moon, it seems to be Enceladus. And though there is a mission planned to Enceladus that's going to be landing here in order to investigate potential signs of life, all of this is not happening until possibly 2050s. And so we're not going to know for sure for at least 20 more years. But all of these signs and all of these observations, along with discoveries of similar moons around other planets, and more importantly, along with discoveries of quite a lot of exoplanets that seem to possess extremely similar density and potentially similar properties to these moons, led to a kind of a hypothetical proposition. What if this is actually where we find most life out there in the entire galaxy? And what if this is actually how life usually begins and how it normally stays for a long time? As a matter of fact, here on planet Earth, it is believed that life might have started around these hydrothermal vents deep in the oceans, which we also believe exist around these moons and very likely exist quite a lot of other planets as well. These regions are usually filled with a lot of different life and represent very unique ecological niches that can survive in this state for a very long time. And so what if this is the face of most alien life out there? And so based on these assumptions, the recent study decided to discover the most likely planets to potentially be the same to Enceladus, thus representing planets with the highest chance for subterranean or technically subglacial life. And the main premise is simple. Life, as we know it, really needs water, liquid water. But except for planet Earth, we don't know of any other object out there that contains liquid water on its surface. Yet we know that some objects, and actually quite a lot of objects, seem to definitely contain liquid oceans underneath the ice. And so maybe that's where we should be looking, and that's the sort of planets we can kind of expect to host something out there. But why would they even have liquid oceans? Well, in order for these planets to maintain liquid oceans, they basically need heat coming from somewhere, and there are two main sources. The first one is the obvious one. Internal heat from the radioactive decay of various elements that stayed inside the planet for billions of years. This can produce some of the internal heat and can also maintain some of the initial geological activity. But the other source is the same source as what we have right here around Enceladus, or actually most moons around large planets. Here we're talking about tidal effects or tidal heating. Tidal heating is the less known effect produced by various objects as they essentially pull and stretch each other because of gravitational effects. We mostly experience tides as the rising and falling of ocean levels. On a lot of other objects, including potentially the moon itself, all of this stretching and twisting also produces quite a lot of heat and quite a lot of energy on the inside. In some more extreme cases, it also basically breaks apart the moon with time forming the rings around certain objects, which is how we believe all gas giants acquire their rings. But in most cases, the moons don't fall apart and instead experience quite a lot of geological activity, such as for example the famous Io. All of the volcanism here is entirely caused by tidal heating from Jupiter and from its neighboring moons. And so something very similar very often happens around planets orbiting certain stars, especially when they're much closer to those stars, and especially in systems that do have several planets. And so, for example, in the very famous TRAPPIST-1 system, where there are 7 terrestrial planets orbiting relatively close to their parent star, we actually expect relatively high tidal effects for pretty much all of these planets, especially the ones much closer to the star, with some of these effects very likely producing something very similar to Io: huge amount of geological activity, potentially a lot of outgassing, and very likely lots and lots of heat for maybe life to survive. But for this particular study, the scientists decided to focus on planets that were maybe just a little bit colder than planet Earth, and also maybe a little bit less dense. The reason they wanted to find those planets are essentially twofold. First, low density implies that there might be quite a lot of water. Any kind of an ocean world, or any kind of a world with a lot of water on the surface, would most likely be slightly less dense than planet Earth, but potentially very similar in size and mass. And the reason they wanted those planets to be a little bit colder is obviously because they were looking for planets that would have ice surface. In other words, they wanted to find planets that would be kind of like Enceladus, just bigger and more massive, but also kind of like Io, in a sense that they would have a lot of volcanism or cryovolcanism, because that's physically something we can see with modern telescopes. And in this case, they've discovered 17 such planets that could be these unusual planets, maybe hosting life. So basically, all 17 currently have an extremely high chance to have a subsurface ocean and a lot of geological activity underneath, representing the best targets for potential biosignatures for modern telescopes. And you can see all 17 of them right here in this list. A lot of them we've discussed before, and some of them we've never really talked about, but for the most part, they're all relatively similar. They would all be somewhat similar to planet Earth, a little bit colder, experiencing high tidal effects. Intriguingly, at least 3 of these planets are in the TRAPPIST-1 system. And intriguingly, the closest exoplanet to us, Proxima Centauri b, is one of them as well. And so, for example, here's how they all kind of compare in terms of internal heating produced by a lot of tidal effects. Of all of them, Proxima Centauri b seems to have the highest tidal heating, whereas the TRAPPIST planets seem to have the lowest, but still kind of similar to planet Earth, which are planet experiences from the moon and from the sun. Io experiences just a little bit more, and as you can see, 9 of these planets seem to have more tidal heating than Io. And though obviously this means that maybe some of these planets look kind of like this, a much more likely scenario does involve these ice worlds with a huge amount of cryovolcanism that should be coming out from every direction, and then deposited somewhere around the planet or around the star system. And since modern telescopes can easily detect this around moons like Enceladus, and we know exactly what to look for, a very similar technique could now be used on those exoplanets by trying to find similar signals somewhere where those planets are. In other words, modern telescopes could physically detect some of this subsurface and geological activity by looking at very specific spectra coming from these cryovolcanoes. And this is something we can physically do now with planets like TRAPPIST-1F. Here's actually that other version of Eyes on Exoplanets that shows you what this planet might look like if it obviously has some kind of a subsurface ocean or maybe even surface ocean with a lot of ice. And because this planet passes in front of its star, it becomes possible to see its emissions, and if we happen to discover something that appears very similar to what we see around Enceladus or Europa, that's going to be a telltale sign that cryovolcanism seems to happen here, and these seem to be indeed larger versions of the moons in the solar system. Moreover, if we find life here, there's a really high chance it might exist here as well. And because unlike Enceladus, the mass of this planet is very similar to planet Earth, with just slightly lower density, this is definitely one of the most exciting objects. Here, a single orbit takes approximately 9.2 days, and so we can actually look at this planet many times to see if any cryovolcanism occurs during this time. But in the list of those 17 planets, 2 are really exciting, or I guess 2 are the best candidates so far, and they're not in the TRAPPIST-1 system. One of them is our neighbor Proxima Centauri b, the closest exoplanet around the closest star to us, roughly around 4 light years away. Here, this planet is also just a little bit colder than Earth and is around the same mass with slightly less density. And according to previous research, it might look something like this. Although honestly, nobody really knows right now what sort of a composition it has, we just know that it has slightly less density. And because of this, one of the assumptions is that maybe it is covered with a lot of water and specifically has a very thick sheet of ice, with possibly 10 to even 20% of the entire planet basically being water. And because it seems to receive the most tidal heating of all the planets, this presents us with an extremely intriguing target. A planet that could be similar to Enceladus, but with more volcanism than Io. Something that would be super intriguing to investigate, except that there is maybe one problem. This is not a transit planet. It does not pass in front of its own star, and so unfortunately, we're not really going to be able to find any ices or any volatiles coming from this planet by looking at its shadow. Instead, something else has to be used in order to confirm what's going on here. Still, once again, this is one of the primary targets and a super intriguing object that, as you might remember, is also the object where scientists might have discovered the first ever extraterrestrial signal, BLC-1, although the conclusion today is that maybe that signal actually came from Earth. You can learn more about this in one of the videos in the description. Either way though, definitely target number 1. But what about target number 2? It's this other planet known as LHS 1140b, roughly around 40 light years away from us, and, just like other planets, is also in the habitable zone, but slightly colder than Earth. Although unlike previous planets, this one is more massive than Earth at approximately 5.6 times the mass. And so technically this is maybe some kind of a super Earth, but also potentially a super Earth that's an ocean world with even more water and even more ice. But also, as you can see from this graph, hundreds of times more geological activity or tidal heating than the moon Io. And though we obviously have no idea what this planet really looks like, this is still an extremely exciting object and has a really high chance right now to also host a lot of life. And because the outgassing here would be extremely similar to what we see around Europa and Enceladus, confirming this is just a matter of time. Basically, by observing this with, for example, James Webb Space Telescope, it will definitely be possible to see these emissions, mostly because a lot of these molecules are extremely easy for infrared telescopes to detect. And so hopefully, in the next few months, someone actually does analyze at least one of these 17 planets, just to provide us with some details and potentially some discoveries. Because at least for now, all of this is just purely theoretical. Nevertheless, at least for now, this is actually the closest we've come to physically finding objects out there with an extremely high chance for some kind of a life based on one assumption. Based on the assumption that objects like Enceladus and Europa also host life inside. And that's of course the first step. The missions that are planned to both Europa and then Enceladus later on are going to serve as a very important stepping stone in order to see if life can exist outside of planet Earth and if it's just as common as some scientists believe. And so if we do find life around one of these objects or even both of these objects, it's extremely likely that all of these 17 planets contain it as well. But the more important question is if we find nothing. If neither Enceladus nor Europa contain any signs of life, that's where we're going to find ourselves questioning everything we know about astrobiology. Maybe rare Earth hypothesis is correct, and maybe life is just as unique as some other scientists believe. And you can learn more about this hypothesis in one of the videos in the description. Anyway, on that note, until future discoveries, or until, I guess, any discoveries in regards to extraterrestrial life, that's all I wanted to mention. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.